Bismillah ar-Rahman ar-Rahim. In this lecture, we have to explain the concept of continuity in calculus. What is continuity? A function is said to be continuous if we draw a graph of the function with one continuous line, means without removing our pencil from graph paper. For example, if we have a pencil, if we draw this curve, this is the graph of continuous function. Now, officially or mathematically, we want to discuss or define the the continuous function. So, definition of continuous function: a function f is continuous at a point x equal to c if and only if function is defined at the mentioned point c, means f of c is defined. This is one point. Second one, limit x tends to c, f of x exists to, means limit at a point c is exists to. Third one, limiting value and defined value must be equal. If these three conditions are satisfied, then we say that the given function is continuous at the given point x equal to c. Once again, a function f is continuous at a point c, if and only if f of c is defined. Second one, limit x tends to c if of x exists. And third one, limiting value and defined value must be equal. Now, we want to explain some example with the help of this definition. First example, given that f of x is equal to x minus 1 at x equal to 2. So, we want to explain the continuity of the given function f of x is equal to x minus 1 at a point x equal to 2. Means here the value of c is equal to 2. Now, first we want to put the value of c at the given in the given function. So f of x is equal to x minus 1. If we substitute the value of x equal to 2 in the given functions, f of 2 is equal to 1. So the defined value is equal to 1. Now we want to evaluate the limit at x equal to 2 of the given function. So limit x tends to 2 of x minus 1 is equal to 1, because in this case the given function x minus 1 is polynomial function, so we substitute directly the value. So the we see that defined value is equal to 1 and limiting value also is equal to 1. So limiting value and defined value is equal as are equal. So therefore the given function is continuous at x equal to 2. Now another example, given that f of x is equal to x square minus 9 divided by x plus 3. So function is given f of x is equal to x square minus 9 divided by x plus 3. So this function is rational function because rational function is the division form of polynomials. So we want to discuss continuity of the given function at a point x is equal to minus 3. First, we have to substitute directly the value of x is equal to minus 3 in the given function. So f of minus 3 is equal to 0 by 0 form. So this is undefined. Means that function is not defined at the given point. Now we want to uh, evaluate limit at x equal to minus 3. So if we evaluate this limit, this will be equal to minus 6. Because x square minus 9, x square minus 9 can be written as x plus 3 into x minus 3. Now x plus 3 cancel with x plus 3. Now by direct substitute we get the value of x with the value as limiting value is equal to minus 6. So clearly the given function is not defined at the given point. Therefore the function is not continuous at the given point x is equal to minus 3. So the function not continuous is not continuous at the given point x equal to minus 3 because the given function not satisfied or not satisfies all conditions of continuity. Now, um, functions that are discontinuous at x equal to a. Now, we want to discuss uh, function that are not continuous are discontinuous at some point x is equal to a. The function is not defined at x equal to a, then the function is not continuous. So in this situation, the graph has a hole at x equal to a. Secondly, the function is defined at x equal to a at x equal to a, but limit x tends to a does not exist. So geometrically, this means that the graph has jump at x equal to a. Thirdly, limit x tends to a exists and f of a is defined, but third condition are not fulfilled. Limiting value and defined value is not equal or not equals. Then in this situation, the graph has a hole at x equal to a. Thirdly, fourth point, if limit x tends to a does not exist, and limit x tends to a f of x is equal to f of a never hold. Then in this situation, the function bellows up at x equal to a. Thank you so much for watching this video. Please subscribe the channel for more informative videos.